Well, here we are looking at the fundamental theorem of calculus. I am pretty sure that you have seen this theorem before and you have used it countless times, actually not only in high school but also in many of the other courses that you're taking while you're taking this calculus course. Okay? What I'm not sure about is whether they have other people have referred to it as the fundamental theorem of calculus, and even less about whether you know why it is so fundamental. So I'm going to start talking about this theorem by telling you why it's so fundamental, right? So we talk about something being fundamental if it's extremely important, if it is something on which everything else or lots of other things are based on and rely on, just like the foundations or even the frame of the barn that these guys are building. So why is this fundamental theorem of calculus so important? Well, it is important for many reasons. It is fundamental for many reasons. The first one is that it actually solves an important mathematical problem, namely the area problem. It finally told mathematicians, after centuries of research and wondering and trying to find out, how to compute through a general method the area of a curved region. Mathematicians had tried to develop sort of single individual formula like the formula for the area of a circle for centuries, and that had been reasonably successful, but not as much as they wanted to because they did not have a general method. The fundamental theorem of calculus allowed them to actually have a tool to compute areas of curved region in its most generality. In practice, you can't always do it for reasons that we're going to see it later, but at least the problem is solved in theory and we know how to do it. The second reason is that it connects two important problems in mathematics. One is, of course, the area problem. The other one was the slope problem. Remember, that was a problem as well, finding out how fast something changes, either graphically, which gives us the slope, or in practice, which gives us simply rates of change. And so both of these are very important mathematical and sometimes even philosophical problems, but people didn't know, hadn't realized how connected they were. Okay? So this fundamental theorem tells us that those are really two sides of the same coin. The next reason is that it allowed the development of many other important applications. I think it's not an exaggeration to say that all the technological development of the last several centuries, 3 or 4 centuries, and most importantly the technological development in the electronic area of the last several decades were made possible by the existence of calculus and of the existence of the fundamental theorem of calculus. It's the one that actually tells us how to connect one thing to another. Okay. Also, just like the foundation of a house, it looks simple. Once we're going to look at it, its statement is quite simple, and yet it is a very powerful tool. Just like the foundations or the frame of a house look simple, but they are the ones that do most of the work when you in fact get to use the house. So let's have a look at what this theorem tells us, starting from a recap of what we have learned about integrals so far, because of course integrals are the key element of this theorem.